Assalamualaikum warahmatullahi wabarakatuh. Saya Ustaz ini Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. So I'm representing from Maju Chemical. So in order to treat wastewater that produced from the production, so we came up with a few wastewater plant in order our wastewater to meet standard B environment standard B, which has been regulated in Environmental Quality Effluent Regulation 2009. We stated that every single wastewater that produced by industry need to be treated according to standard B. So in our wastewater treatment plant, we have find a few treatment, which is primary treatment, secondary treatment, and tertiary treatment in our wastewater plant. So the first phase of the treatment is the primary treatment, which consists of pH tank, consists of coagulant tank, and consists of flocculant tank, and then proceed by first clarifier. Wastewater that produced by the Maju company usually has a range of pH between 3 to 4.5 as stated in the question. So in order to enhance a neutral pH, you need to be retreat first in the pH tank. So in the pH tank, usually chemical base is added in the pH tank, which is purpose to remove dissolved solid and increase the pH of the wastewater itself. This step also has been taken in order to ensure smooth flow for the next section. And proceed by the next section, which is the coagulant tank. For me, coagulant tank is one of the important step in primary treatment, where in the coagulant tank, alum usually will be added in the process, which is a chemical compound they exhibit a cation properties. So these cation properties will attract dissolved solid and create neutral charge particle. So this particle then will stick together, producing a large particle. Usually in coagulant tank, they will be introduced in a rapid mixing in order to allow particle to be introduced distributed evenly. Then they proceed after the coagulant tank. Usually the wastewater will proceed to the flocculant tank. So flocculant tank is served in order to provide, in order to bring the particle that been formed from previous coagulant process together and produce flocculation. Usually in flocculant tank, we have a pedal provide slow mixing. So this slow mixing is to enhance a formation of the flocculant compared to the coagulant tank, which is introduced rapid mixing. So let's say example, flocculant tank we introduced with rapid mixing. The flocculant that we form, the particle that we form will break. So next, after the flocculant tank, the last step at the primary treatment is the first clarifier. So in first clarifier, the setting process will take form, which is occur due to the detention time of the first clarifier itself, where we assume and it is estimated to be around 5 minute detention time. So the flocculant that formed from the previous flocculant tank will settling as the suspended solid in the clarifier and exit at the bottom of the clarifier itself. So once it's settling down to the first clarifier, we consider it as a sludge. So a sludge will be collected at the sludge tank, and then the sludge collected will be sent to the slush treatment. They will be introduced in a rapid mixing in order to allow particle to be introduced distributed evenly. Then they proceed after the coagulant tank. Usually the wastewater will proceed to the flocculant tank. So flocculant tank is served in order to provide, in order to bring the particle that been formed from previous coagulant process together and produce flocculation. Usually in flocculant tank, we have a pedal provide slow mixing. So this slow mixing is to enhance a formation of the flocculant compared to the coagulant tank, which is introduced rapid mixing. So let's say example, flocculant tank we introduce with rapid mixing. The flocculant that we form, the particle that we form will break. So next, after the flocculant tank, the last step at the primary treatment is the first clarifier. So in first clarifier, the setting process will take form, which is occur due to the detention time of the first clarifier itself, where we assume and it is estimated to be around 5 minute detention time. So the flocculant that formed from the previous flocculant tank will settling as the suspended solid in the clarifier and exit at the bottom of the clarifier itself. So once it's settling down to the first clarifier, we consider it as a slush. So a slush will be collected at the slush tank, and then the slush collected will be sent to the slush treatment. So that's a little brief of primary treatment from us, and we proceed with secondary treatment.
From Maju Chemical, we have a lot of chemical being the influence from the company itself. So after the primary treatment, we will move to the secondary treatment, which the secondary treatment will focus on BOD and COD and the microorganism. Okay, first of all, the first step for secondary treatment is for the pH tank. For the pH tank, the effluent released by the chemical is actually 4.8. But according to Environmental Effluent Industrial Effluent Regulation 2009, the pH released by the company is acidic, is below the range allowed to be released to the environment. So we have to ensure the pH value is in the range before we can proceed to the next step. So next step is aerator tank. Aerator tank, we have a lot of type of aerator tank, but we chose the waterfall aeration tank, which the waterfall is the first we pump the air into the tank, but then we pump the water inside the tank, and inside the tank we will have a stack or shelf, which it will increase the surface area of the water to interact with water, with air. After the aerator tank, the wastewater is pumped into the second clarifier. The concept of second clarifier, we use it the same as the first clarifier in the primary treatment. And in the aerator tank, we have the shelf and stack to increase the efficiency and contact between the air and water. So after we done with the secondary treatment, we will move to the last but not least, the tertiary treatment, before we can release the water into the environment. Okay, in the fresh mixer, which use the same concept as the flocculant tank, which alum will be added in the fresh mixer so that it will produce a flock. The flock actually will be trapped in the sand filter, and the sand filter will be backwashed every 24 hours to the primary treatment, because the flock will be trapped in the sand. After 24 hours, it will cause clogging at the temperature. So every 24 hours, it will be get washed to the primary treatment. After the process is done at self-filter tank, the wastewater will actually move to discharge tank. At discharge tank, there actually will be added a certain chemical such as chlorine and sodium bisulfite. Chlorine is added to disinfect water with microorganisms, and sodium bisulfite is removed if and only if the chlorine is added exceeding the allowed amount. And after they are done with the discharge tank, the water can be released to the environment.
Standard. According to standard. According to standard B. Okay.
Okay, that's all.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Firdaus. So we are going to proceed our video with air pollution. So basically, the air pollution meaning is one of the type of pollution occurred by emission of contaminant in a gas or particulate matter form. Okay, however, the air pollution can be controlled or reduce its contaminant by dilution or control exhaust, which is by using a specific control devices. Right. Okay, based on the Maju chemical plant waste data, we obtain that there are three part of emission, which is the first one is the flue gas type, the second one is at the process step 1, and the last one is the process step 2. Okay, at the flue gas step, the contaminant take before the emits is a particulate matter, sulfur dioxide, and nitrogen dioxide. The particulate matter at the flue gas type data exceed the limit value set or gazetted by the Environmental Quality Regulation 2014. Okay, so this air contaminant particulate matter need to be treated before emits to the surrounding. Alright, so the first control device we choose in order to control the particulate matter is a cyclone separator. Okay, so the operating standard condition or theoretical operate for cyclone separator is by this schematic diagram. Okay, so this is for particulate matter remover at the flue gas tank. Okay, the dirty gas air will enter the cyclone at the site of cyclone, and then the heavy particulate matter will circulate in the cyclone and going down to the bottom of the cyclone. However, the clean gas without particulate matter will be gassing at the top of the cyclone.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Faizi. So I will present about the uses of equipment of HCl and chlorine, which is in the process step 2. HCl and chlorine will use condenser, which is similar to the process of shell and tube condenser. So how the condenser operates? Condenser works when the warmer vapor stream contacts the cooling medium. The heat from the warm gases is transferred to the cooler medium. Condenser used for pollution control are contact condenser and surface condenser. Direct contact condenser operate by mixing the contaminated gas stream with the cooling medium. Indirect or surface condenser work when the contaminated gas stream is kept separate from the cooler medium, similar to a radiator or heat exchanger. As for spray tower, the compound that use spray tower in the flue gas is SO2, and in the process step 1 is ammonia. So how the spray tower works? First of all, dirty gas in, when dirty gas in, it enters and the water, the spray tower will produce water, and the dirty gas will flow out at the bottom, while the clean gas will take out from the top of the spray tower.
Assalamualaikum and good morning. My name is Muhammad Nazmi, and I will explain on the waste management of solid waste produced from Maju Chemical Company. Okay, Maju Chemical Company produce solid waste and a scheduled waste. So for a solid waste, they have produced waste such as discarded container and barrels, and kitchen waste and trash. So, first, kitchen waste. Kitchen waste is mainly came from canteen, which is consists of organic waste such as leftover food and excess food from food preparation. And then for the waste management of kitchen waste, we can use an composting process, which is there are two types of compost. The first is aerobic process, and second is an aerobic process. But the aerobic process will produce compost that can be used as fertilizer for plants, and from an aerobic process will produce methane gas, and the methane gas can be used to generate power for the factory. And second is trash. Trash is mainly from office and kitchen in the office area. So mainly the trash came from office area is consists of largely paper, cardboard, and food packaging that came from the kitchen. In order to reduce the waste from the trash, we can perform a recycling method. We separate the product into recyclable waste and non-recyclable waste, and then for the non-recyclable waste, we can dispose them as the municipal waste. And then for disposable container and barrels. So usually from chemical company, this containers is used as to hold or to store the raw material or product of the chemical, which contain hazardous effect to our health. Hence, we need to dispose this unused container through the waste management contractor, which is SWM Environment and Alam Flora Sdn Bhd.
My name is Linda. I will explain to you what the scheduled waste that produced from the Maju Chemicals. So Maju Chemicals has produced 4 scheduled waste, which is IETS sludge, used oil, spent solvent, and spent catalyst. So the different waste, we use the different labeling for the labeling. The labeling is the purpose is for to put on the container, so the people will alert about the hazardous waste that put on the inside the container. So first is the IETS sludge. We know that IETS sludge is the any deposit that come from treatment or chemical reaction, which it can be formed of solid, liquid, or any deposited. So IETS sludge, the hazard symbol is toxic, and the container that we use to store the IETS sludge is open top drum with cover and clamp, which made from steel. The container is usually is in black in color. For the second waste is spent solvent. So spent solvent is the solvent that we don't want to further use, so we put it as the spent solvent. So spent solvent, we know that it can be flammable and it can be reactive and can be corrosive, because spent solvent can be made from acid, alkali, and alcohol. So the hazard level that involved in spent solvent is flammable, corrosive, and toxic. And the container that can be used to store the spent solvent is bunghole drum, which made from plastic, because you cannot use the steel, because it will the steel will react with the metal inside the spent solvent. And the next is spent catalyst. We know that catalyst can be made from liquid or solid. So the spent catalyst that produced from Maju chemicals can be either in explosive or flammable. So the hazard symbol that produced for hazard symbol that used for the spent catalyst is bahan letupan, which is explosive and flammable. And the container that used is open top drum with cover and clamp. It seems like the IETS sludge, but it in plastic. So the lastly is use oil. We know that oil is a flammable because it can easily react with the fire. So the sample that used for the use oil is flammable, and the container that used to store the use oil is intermediate bulk container. That's all for me. Thank you.